Hey, good afternoon, everyone. I'm Rob Quiros. I'm with SOHO Systems, and I have a bit of a talk here about how to tackle security as you move apps into the cloud. So why don't we get started? Thanks for coming by. So I want to start with a question. Does everybody know how this security model in the cloud works? So what is your responsibility in terms of securing your applications into the cloud? There's a lot of companies using the cloud are really not following best practices today in terms of how they secure their applications in the cloud. So if you're not really following best practices, you're pretty much just going naked in the cloud, kind of like this guy here, right? Where you're basically exposing your infrastructure and your applications to the threats on the internet. So why would you do this? Why would anybody take the risks of exposing their applications to the threats on the internet? Well, one key difference as people have moved their applications from inside their data centers into the cloud is where the users are actually coming from. So in the old model, your users were inside your data center, surrounded by a nice security perimeter on the same network as your applications. But when you move those applications into the cloud, your users obviously can't be on the same network as your apps. They can't be in the cloud. So your users have to come in from outside the cloud, and that typically means bringing them in from the internet, right? So if you're going to bring in users from the internet, that means you're going to have to open up a security hole into your cloud, allow those users to come in, and take the risk of allowing other bad things in, DDoS attacks, malware. Your users may have compromised credentials, so the hackers may be able to get in through those paths as well. These are obviously a lot of risks to take, and you don't want to have to do that if you don't have to. So let's take a little quick look at what this shared security responsibility model looks like from the Amazon AWS or the Azure perspective. Most other cloud providers are doing this as well. So the cloud providers themselves do provide a lot of security around their infrastructure. They also secure the virtualization layer, the hypervisor that you're running on, but they make it your responsibility to secure what you're running on top of their infrastructure and hypervisors, right? So your host operating system, you're responsible for patching that, you're responsible for antivirus, and for your applications, you're responsible for providing the security around those applications to allow the good users in and to keep the bad users out effectively. So how are companies tackling their responsibility today? There's basically two models. So solution number one is take the traditional approach. Build a security perimeter in the cloud like you traditionally have built it inside the data center. So that means you're probably going to go and pull in some open source firewalls, WAFs, IDSs, WAN optimization potentially, DDoS protection. You might also just buy these things from off the shelf from vendors, traditional vendors like F5 and Cisco and Riverbed and those sorts of vendors. Well, once you've basically gone through the process of acquiring all of these devices, you're going to have to deal with two different problems. One is, how do I route all of my traffic through each of those devices? Remembering that it's not your network that you're putting these devices on anymore in the cloud. It's the cloud provider's network. The other one you're going to have to deal with is, how do I set up high availability of this cluster of devices inside the cloud? So you're probably going to end up buying two of each one of these or instantiating two of each one, setting up an overlay network, and basically going through a lot of expense just to build the basic perimeter. And then you have to do the next step, which is you have to figure out who the good guys are. So you have to authenticate them to your directories. Maybe it's an Active Directory back in your data center. Maybe it's a SAML provider like an Okta or a Ping. So you're going to have to create the connections between your infrastructure in the cloud and those directories. And next, once you let those users in, you're going to have to figure out, well, what did they access? You have to keep the logs and do log analysis for compliance to make sure that the users were accessing only the applications that they were supposed to. So you're going to build a Splunk and a database inside of your network as well, or inside your cloud. I forgot about your admins, of course. Your admins now have to get in and they have to create policies. They have to access all of these devices, push policies to all of them, and of course manage all the policies across all those devices. So clearly, this is not an approach that a lot of people take, because this is what you have to do to set it up in one cloud. And typically, for most adopters of the cloud, you've got tens of clouds. You've got maybe a VPC for finance, a VPC for marketing, 3 VPCs for engineering. You can't possibly go and set up this kind of perimeter in every cloud. Because basically, even in that one cloud, it's going to take 6 months, 3 engineers, and $100,000 to do it. So a lot of companies are opting for option 2, which is to basically open up some security groups in your cloud, whitelist some IPs, and give your apps a public IP address. And so this is just only slightly better than just exposing everything to the internet. You're essentially doing little more than going naked in the cloud with this approach. You know, your enterprise applications, internal applications, even development tools like Jira and Jenkins that you put in the cloud were never designed to be exposed to threats on the internet. They're not designed to be able to take a DDoS attack or to survive a SQL injection attack. These things are, those sorts of protections were always built on the network side of things. So opening up your internal network in the cloud, whitelisting IPs and VPNs is really just inviting disaster. Well, we decided to do a little experiment at SOHO. We created a VPC in the cloud. We put a particularly vulnerable application. I'm not going to say it was one of the best, but we put this application up in a VPC. We gave it a public IP address, and we just let it go. See what would happen. 4 hours later, 4 hours, we got this note from Amazon that hackers had got in. They'd found our application. They'd cracked the root password, and they'd recruited it into a botnet. So we were now helping this attacker go and do a DDoS attack on somebody else. Clearly against the rules as far as Amazon's concerned. So how do you protect yourself? How do you both solve the security problem yet remain agile in the cloud without having to go through all this expense of building the security yourself? What if you could hide your applications from the internet without having to build all that traditional security infrastructure, without having to go naked in the cloud, and you could do it in about 15 minutes? So that's what my company SOHO Systems is doing. We are allowing you to tackle your side of the shared responsibility, shared security responsibility model in the cloud through our service, which you can set up very easily inside of your network across all of your clouds in about 15 minutes. Essentially, we're making all of your clouds invisible on the internet and moving the security out of your clouds to our main cloud that sits on the internet. So how this works is we have a 2-part service here. It's all software. There's no appliances. There's no hardware to install anywhere. Our main cloud is where the users come in and we apply the security. And then we have a piece of our service called the Cloudlet, which is a virtual machine or an AMI inside of Amazon that sits inside of your cloud and is essentially proxying connectivity in and out. Now this Cloudlet has this unique property that it only ever dials out to our cloud. So you can lock down your cloud to all inbound access. And by doing that, you're basically taking it off the internet and moving all of the security responsibility to us. So how do your users get to these applications? Well, basically, they're going to take any device, a phone, a tablet, their laptop, anything with a browser, and type in a public URL to get to this application. Now that URL is going to redirect those users to our main cloud that's on the internet, where we're going to authenticate them against your directories. So we have the ability to connect into your Active Directory inside your data center, or to your Okta or your Ping, or you can even set up a directory inside of our service for temporary access from partners. And then we'll authenticate them. We'll apply 2-factor authentication, multi-factor authentication. We have access policies, basically to make sure that this user is a good guy, that you know who he is. only after we know that this is an authenticated, authorized user to access that application will we signal to that cloud that lives inside of your data center or inside of your cloud to dial out a connection, and that connection will meet that user coming in inside of our cloud, where we'll stitch together the full path and encrypt it to that application. So you never have to expose the application on the internet. The users get access through any device, through a browser, as if they would access Gmail or any other SaaS application. In fact, sometimes I like to say we help you SaaSify your internal applications that you're running in your cloud. So we've built the service to be highly available, highly scalable. We're using global DNS to get the users into our cloud. Our clouds themselves, the clouds that sit on the internet, are internally very highly available and scalable in terms of their architecture. But the clouds themselves are redundant. So if any one of our clouds goes down, your users will get redirected to a backup cloud where they'll then be able to get a path into your network. The cloudlets themselves can be redundant inside of your clouds. You can have 2 for high availability or 3 to scale up and have n+1 redundancy. And the cloudlets themselves will do server load balancing to your application front ends. So end to end, from the user all the way to the application, this is a very highly available and scalable infrastructure. So, you know, it's really easy now with a service like ours to be able to go and take advantage of multiple clouds, to be able to set up your applications without having to go and knock on the security guy's door and wait 6 months to get a perimeter set up. You can basically do it in 15 minutes, and you can do it yourself. We have a free trial that you can sign up for and give it a whirl, see how it works for you. Never have to go naked in the cloud, just have to get SOHO. So to learn more, we have a demo going on at our booth, number 131. We invite you to stop by. I'd love to talk to you some more about what we're doing, and have a great show. Thanks very much.